Okay, so let's continue. I'm gonna just continue making this whole big subroutine. Again, like I said in the last video, it may just be a lot of the same stuff, but maybe some of it is relevant to what you're doing. So I'm just gonna record it for those people that want to see it. So let's continue with room 0. We have the right door, but we did not draw this bottom door, and that is the door number 2. So let's go here. We're going to load door states 0 through 7. We're going to AND with door 2. We're going to break if it is equal to the end of the subroutine down here. Otherwise, we're going to JSR draw bottom door. Now we have to draw write this function, which literally is going to be the same as draw right door. So I'm going to copy paste this. Draw bottom door. Oops, draw. I wrote door twice. And we just change this from right to bottom. Right to bottom. And while we're here, let's just do the same thing for top and left, because we're going to need those eventually. So while we're here cutting and pasting, we will do so. Left, 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 and what do we have left? The top. Oops. All right, let me do a bit of organization. I usually go top, bottom, left, right. So top, bottom, left, and right. Perfect. So now we can just call these just like we did up here with jump to subroutine, draw bottom door, draw right door, yada, yada. So room 0 doors is completed. We can go up here and setup and toggle those bits again. So door 0 and door 2. Oops, I just wrote a 2. It should be a 1. We can assemble this. Ooh, unknown label, 591. That's probably when we cut and paste some stuff. 591. Bottom door. Ooh, bottom door. Bottom door. And that's probably what that other one was. Bam. Okay, let's go to room 0, just like we did before. And that door did not toggle. So either we didn't toggle the correct bit, or our room 0 function's broken. So 0, 1, 2. That is the correct bit. Oh, we did that in the comment. I feel like an idiot. Okay, so load door 0 into door states, where actually we want to instead we load door states 0 through 7, and we OR the doors we want to toggle on and off. So door 0, store into door states, which this is silly what I'm doing. Let's just go back to binary. I know the readable aliases were helpful, but this is just in setup for testing purposes. So let's toggle bit 1, bit 2, and we store that in door states 0 through 7. Okay, so this should draw correctly. That's sometimes the danger of having comments that look like they're editable. Ah, there we go. There's the doors. and they should disappear. Bam. Because we've traversed into a room in which those doors aren't relevant. And I don't know how well you can see it on YouTube. I'm actually getting 1 frame delay on when the room loads and when the sprites actually load. So what I can do to counteract that is where we're turning on the screen. So we go to, we're writing to index 2000. So it's in our exit routine. When we waited this V blank, and then we've turned on our screen, we haven't updated any of the graphics, because the screen can turn on, but the NMI could be 1 frame behind it. So let's either jump to NMI afterwards. No, we don't want to jump to NMI. Let's just update sprites here. So JSR update sprites. Before, like the instant before we turn on the screen. After the V blank, before the screen turns on. And that should fix that little frame of difference that I'm seeing. Again, you may not see it on YouTube. Okay, so that's fixed that. It's instantaneous. The doors load as if they're part of the background texture, which is what I wanted. Because when things kind of flicker in and out, it kind of takes you out of it. It just looks disjointed. So that has fixed that. So let's worry about room 2 now, because this is where it gets interesting. We have this single bit per this room. So once we actually manage the room doors loading in and out when they're relevant, that single bit is going to take care of if we're in room 0, we see the right door. If we're in room 1, we see the left door. And it's that single bit taking care of it all. So let's go all the way down to where we're writing all this and make another branch. So we compare now. So since we've loaded the index, we compare with 1. Branch of it is equal. Room 1 doors. Okay, let's write that. Room 1 doors. We're loading door states like normal. 0 through 7. And now what doors are we worried about? Let's go back. So room 1 contains a left door, a right door, and a bottom door. Let's kind of put those on our notes. So room 1 contains left, right, and bottom doors. The left one is door 0. The right one is 1. The bottom one is 3. Right 1, bottom 3. Okay. So let's first check door 0. Break if it is equal to skip. Otherwise, if it actually renders a 1 and door 0 is present, we jump to subroutine, draw left door. Bam. So let's check that that's true. Let's go up. Bam, we drew the left door because door 0 is toggled on. Let's walk through this door because there's no collision. Bam, the right door is also drawn because that's, again, door 0. And if I toggle off door 0, I know I'm really driving this into you hard, but this is where the flexibility comes in. It's literally toggling a bit to 0. We render this out, and bam, left door not drawn in room 1, right door not drawn in room 0, because they're literally, if this door is open and I walk through it, it makes no sense to come out of the other end and have a door locked. So let's continue on. Bum, ba, ba. So that one is taken care of. What happens next? We load door states 0 through 7. We're going to do that an awful lot. We AND with the next door we want to check. The right door is door 1. So we AND with door 1. Break if not equal to skip. Otherwise, we jump to subroutine and draw right door. Okay. Let's just get the other one in here. I think we got the idea. We don't have to test it every single time. Well, in reality, you would want to test very, very often and just make sure things are working, but this is simple enough to where I know it's going to be working. So load door states 0 through 7. What's the last door? The bottom door is door 3. So we AND it, or door 3. Break if it is equal to the end. Otherwise, if it is an active door, we draw bottom door. Draw bottom door. Okay. So let's just toggle those, make sure those are working. I'm just going to toggle all of them. 1, 2, 3, 4. So that's 0, 1, 2, 3. We have the bottom, the left, and the right. So we have 0, 1, and 3. And the other one, all those are toggled on. So as I go through these, I'm just going to toggle on the one I'm testing, make sure it turns on. And I may speed up the video here. I'm literally just doing the same process for every single room. I may stop once I start getting to this section. So I'm going to fast forward the video. Once I get to this section where this other byte comes into play, we're going to pick back up, because literally all I'm doing is the same process. Take note of what doors the room 2 has. It has a left door. It has a bottom door. What is the left door? Door 1. We AND with door 1. We compare. We jump to subroutine, draw left door. On room 2, we AND the state with door 4. If it passes the branch, we draw bottom door. Same process. So I'm going to get those done and meet you again when we're going to start talking about checking this second byte. Okay, so we've hit room 4, for example, and it's going to have a top door, a left door, a right door, and a bottom door. But we've hit an interesting spot because this bottom door, for example, is going to be door number 8. And remember, that was in that second byte of the door states. So we have to kind of keep that in mind when we're adding this next routine. So I'm just going to continue adding this stuff. So we have load door states, capitalization, 0 through 7. And if we look at these doors, this happens 3 times. So I'm just going to copy that 3 times. And then the bottom door is going to be load door states 8 through B. 8 through B. Oh, and I misspelled this. Doors states is not a label. It's door states. Okay. So let's AND with the top door. And what door number is that? Door number 3. Door 3. Break equal. Next. And that is jump to subroutine, draw top door. Next one. Draw left door, compare with door 5. And door 5, break if equal, jump, draw left door. Next one. Right door, and with door 6. And door 6, jump to subroutine, draw right door. And now we've hit this load door states 8 through B. So AND with 8, load bottom door. Oh, sorry. Yeah, AND with 8, load bottom door. 8. JSR. Draw bottom door, not load bottom door. Okay, let's double check things are working. I always like to periodically check because now we're in this portion where we can check door states 8 through B. So let's toggle on a door in setup, load binary number of this value, store it in door states 8 through B. All right, and that should, upon loading the lobby, which we're going to spawn in, put a door at the bottom. Oh, perfect timing. So I knew this would happen. So we've actually branched out of range. And that's due to this huge long format that we're using. Let's go to here. So you see this load, compare, branch, compare, branch, compare, branch. And then it goes to these individual functions here. And we've just been growing and growing this downwards. There eventually becomes a state where this branch instruction is never going to reach that label because the branch can only branch forward 127 bytes or backwards 128 bytes. So there's a very limited range there. So to counteract this, I'm just going to create kind of a hack. So instead of using the branch instruction, we can use the jump instruction. And the jump instruction will jump anywhere you give it. So I'm just going to add a bunch of cursors. We're going to copy all that. We're going to paste them down here. We're going to say jump. Like that. And then these are all going to I'm going to modify the ends of them with a J real quick. And then this will branch to here. This will branch to here. And so on. Oops, I copied the same thing. That should be a 2. Room 0, 1, 2, 3, 4, 5, 6. Okay, I just had one small error. 2 was a double 1. So 3. Four. 5, 6, 7, and I missed one. Oh, room 5 here. No, room 5. Oh, this wasn't underneath the proper label. Doi. And then 8. Okay, so this should fix that branch out of range because we're literally just branched conveniently to a spot down here, and then that jumps to the proper location. Hopefully I have no errors. Bam, fixed. And we've drawn door 8, which was what I originally wanted to show you, because that's part of the second set of bits. Okay, so now that that jump table is there, I'm just going to continue the line. I'm going to speed up the footage. This is a lot of the same stuff. I'm just keeping track now of this 9-bit being in the second grouping of states, whereas these 4 and 6s are going to be in the first grouping of states. So I'm going to continue adding all that in. Okay, I'm glad we got through that. That was a lot of stuff to kind of get down, just a lot of typing in general. Although the core mechanic I hope was understood, even though it was just a lot of monotonous, just keeping track of unique doors per which room you're in and just kind of indexing into those properly. But now we have a system in which a bit corresponds to like a portal, like a door into another room, and it draws the barrier accordingly. Next, I want to work on collision. So these are currently still just portals in which the character can walk through. Next, we have to worry about if a door is drawn, make sure that the collision is updated. So I don't want the character just to be able to walk through locked doors. It doesn't make for a very interesting game. I'm going to start releasing the source code. So in the description below, you can find this current source code here. And you can get kind of a more close eye on it. You can kind of dig through it. I know, like in the video, it's easy enough to just kind of type along, but to kind of see how all the things are interworking together, I'll let you kind of scroll through that at your leisure. So those files are down below. I will see you in the next episode. Bye.